Hi, welcome to part 16 of the video series on vertical projectile motion. In the previous videos, we explained the topic. In the next few videos, we will solve some examples to review this chapter. The position time graph for a ball thrown vertically downwards from the top of a 48 meters tall building is shown below. The graph is not drawn to scale. The ball bounces off the ground, reaching a maximum height of 8 meters. Ignore the effect of air resistance. Calculate the speed at which the ball is thrown downwards. Before starting with the solution, we have to decide on the positive direction. As mentioned in the third part of this video series, it is advisable to choose the direction of initial velocity as the positive one. Since the object is thrown downwards, we will choose it as the positive direction. All equations of motion used in this topic involve the final velocity, except for the equation to calculate the displacement using the initial velocity and time. The displacement of the ball is 48 meters, as it falls from a height of 48 meters to the ground. The time it takes for the ball to hit the ground is 2.8 seconds, and the gravitational acceleration is 9.8 meters per second square. 1 over 2 times 9.8 times square of 2.8 is 38.416. The initial velocity times 2.8 is then equal to the difference between 48 and 38.416, which is 9.584. To calculate the initial velocity, we have to divide it by 2.8. The answer, rounded to 2 decimal places, is 3.42 meters per second. In the second part of the question, we are asked to calculate the speed at which the ball hits the ground. As the initial velocity is already known, we can use the equation V final is equal to V initial plus A times delta t to calculate the final velocity. The initial velocity is 3.42 meters per second, the gravitational acceleration is 9.8 meters per second square, and the time it takes the ball to hit the ground is 2.8 seconds. The final velocity at which the ball hits the ground is 30.86 meters per second. For the third part of the question, we must calculate the speed at which the ball bounces off the surface. The only information related to time in this part of the question is the time the ball bounces off, which is not very helpful. Therefore, to solve this question, we are going to use an equation that doesn't involve time. V final square is equal to V initial square plus 2 times A times delta x. The velocity of the object at the maximum height is equal to 0, and the gravitational acceleration is 9.8 meters per second square. The motion of the ball after the bounce starts at the ground and ends at a height of 8 meters, which means the object has been displaced 8 meters in the upwards direction. As we consider downwards as the positive direction, the displacement of the ball will have a negative value. 2 times 9.8 times minus 8 is equal to minus 156.8. Hence, the square of the final velocity is also 156.8. To calculate the final velocity itself, we must take the square root of this value. After bouncing, the ball moves upwards, so its velocity must have a negative value. In this case, we are asked to calculate the speed of the ball. As speed is a scalar quantity, its value is positive 12.5 meters per second. In the last part of the question, we need to draw a velocity time graph which is not to scale for the entire motion of the ball. While doing so, we have to indicate the following values on the graph. The initial velocity with which the ball was thrown, velocity with which the ball hits the ground, time taken to attain this velocity, and the velocity with which the ball bounces off the ground. Before starting with the solution, let's display the values we have already calculated in the previous parts. Take note that the velocity after bouncing has a negative value here. The ball is thrown downwards at a velocity of 3.42 meters per second, which is the point from which we will start plotting the graph. After 2.8 seconds, its velocity becomes 30.86 meters per second, which is the next point on the graph. For vertical projectile motion, The velocity graph is a linear function. Once the ball hits the ground, it bounces off with a velocity of minus 12.52 meters per second, which is the next point from where we will continue to plot the graph. After bouncing off, the ball will move upwards and slow down until its velocity becomes zero at the maximum height. In this video, we have solved an example related to an object thrown downwards from the top of a building. In the next video, we are going to solve an example involving a hot air balloon. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.